And we're going to close with a panel session. So we're going to get Sylvie, David, and Darminder. So it's going to be like a hybrid panel session. So this is a challenge. So we're going to have two virtual panelists, and Darminder and I are going to sit here. So we're going to be very small compared to the two virtual ones. And Sylvie there? Yeah, great. And I'm going to start off by asking each of the panelists to just give a short answer to a question. So the question we're going to ask the panelists, and then we'll open up to everybody so you can ask whatever questions you want. So if there are questions you didn't get to ask them before, you can pretend it's in response to the panel discussion, but just sneak it in. The question I wanted to ask was, what do you think is the largest barrier to responsible development of AI in the next 5 years? And what would be one solution to help overcome that barrier? So let's kick off perhaps with, shall we kick off with Sylvie? And then we'll have David and then Darminder, so that you get a bit of a rest after you talk. No worries. Yeah. Okay, we can take a seat down. Good. Green or red?
Okay, I guess I should try to answer that briefly. Well, I think I can tie to the talk I was giving earlier, since I was trying to take the point of view of a critique of definitions of data. Yeah, it's as if like definitions of data have been hijacked in a way by, in my metaphor, those who build water mills or people who exploit data for basically to power industries, right? So data has then been defined as an asset, which gives rise to exclusive property rights. Now, it's unhelpful for a number of reasons, and I'm not going to go now into bottom-up data governance. I've done that. What I want to talk about in this case, which is really a live issue for me, is what I worry about the extent to which, you know, when we look at the kind of creatures we are, we humans, yes, we do deliberate from time to time. So yes, we do try to exercise reflective agency from time to time. But most of the time, our intelligence is intuitive. It's formed on the back of habits that are acquired through experience, right? And what I worry about is that so far there hasn't been enough attention and work devoted to the way in which the tools we're developing now at a fast speed and that interact with us, whether it's in the domain of public services or whether it's in the domain of, say, tools to help us make better decisions, whether it's my trying to buy better books or deciding who I should meet next, or so there's a very wide range of applications, right, where you can try to optimize our experiences, optimize our choices. And what I worry about here is the way in which these tools are designed with above and everything else, a consideration for optimizing towards efficiency. Yeah, so the idea is that we should spend time with people who are most like us, for instance, because that will maximize the time we spend online. That's one of the ways of optimizing, etc. And what we are not really paying due attention to, I think, is the way in which, in order for us to retain this intuitive habitual intelligence, we actually need to be able to experiment continually with our environments. Okay, what do I mean by experimenting? I mean co-constructing, effectively trying things. So what I worry about is that most of the, let's call them AI tools with quotation marks, so I'm always iffy about what it means, but the design of these tools in a wide range of applications, yeah, in public services and also in our private lives, is not giving due credit to the need for intelligent interaction with these tools. And what I mean by intelligent interaction is an opportunity for co-construction, effectively. Now, I'm sure when I talk to, I mean, the audience here is mostly constituted of computer scientists, data scientists. you're going to say, well, can you be a bit more concrete, Sylvie? Yeah, what do you mean by co-construction? How do I translate that nice word into a practical solution? Well, I hear you. I think we philosophers and lawyers shouldn't remain abstract all the time. And so one of the things that I've been trying to work out is what I called, well, I've called them ensemble machine learning techniques, in the sense that it's a way of saying, can we build machine learning tools in a way that gives an insight into what the alternative outputs could be had a machine learning algorithm being trained differently or on different data. And then once you have this view of like counterfactual outputs, you can more intelligently, as an individual interacting with that system, have an understanding of what could be otherwise and how you could give feedback that could change the design of those tools, right? So I hope I'm making sense. It's difficult here orally. I've tried to develop that in a paper I published recently in Journal for Cross-Disciplinary Computer Science, but effectively what I think is the biggest obstacle, to wrap up, is lack of opportunities for co-construction. Stop there.
Thanks, Sylvie. Okay, we'll move on to David now.
Sure, thank you. I guess I'm gonna actually take a radical departure from my talk and say something a little controversial as well. That I thought about this, and for me, I want to say that's the biggest challenge I see, or one of the biggest challenges is really this dimension of anthropomorphic deception or anthropomorphic confusion that we're seeing arise more and more with these large language models and these foundational models that are really good pattern matchers, and that really kind of sort of inspire people to see human traits in the technology that simply are not there at the moment. I think I would say that over the next few years, as the models get bigger and they're working, they have more parameters, how many hundreds of billions of parameters, and they've got more data, they'll become increasingly effective at reproducing patterns that seem like they're coming from common sense, people who have common sense, who speak language, and all these other things. And I see there's a problem here, because already with what's happened this past couple of weeks with this whole this lambda sentient, and then we hear other examples of people just kind of becoming enamored with these very sophisticated large language models. I want to say that we need to be careful here. We need to understand the science and understand that at the end of the day, this is software running on hardware, and it's not necessarily representative either of the social character of communication, the way that humans interact and understand each other. We call it linguistic intersubjectivity. And also the way in which we make proper connections and emotional bonds with each other in the real world. And so I think that we just need to be really careful, because there's been a tendency over the last few generations in computer science and AI in general to take a very behavioralist perspective in many ways on what intelligence is, how to operationalize concepts like intelligence. And I think that can lead us down very dangerous and unhelpful paths when we come right down to it. And there's nothing new under the sun here. I mean, already, was it 40 or 50 years ago, Weizenbaum created this very simple chatbot called Eliza, and was just a rule-based system, very, very simple. And yet even Eliza, we know that Eliza was just basically operating on a simple set of rules and didn't have intention or the characteristic features of human judgment cognition. And yet, and why this was Weizenbaum, it's called the Eliza effect. This was Weizenbaum's kind of, he was terrified at this, that people are just so willing to sort of buy into the potentially counterfeit character of anything that they're interacting with, be it Roomba or Eliza or Lambda. So in order to get around this, I think that what we really need to do is to upskill and educate folks about what's actually going on in the technology, so they understand that even if it's a large language model, even if it's opaque, at the end of the day, I mean, this is mathematics. It's statistics and probability theory, etc. It's not necessarily world making through language and through social interaction, which I think is it's a category error to mix the two together.
Okay, thanks. So maybe time to put the Turing test to bed.
Or yeah, if not put the Turing test to bed, I think it's time to understand. I know Sylvie is going to want to jump in on this too, but I think there's a longer conversation about what was actually going on when Turing wrote that paper, and what he was actually claiming in that paper. I think the paper's been appropriated for generations now in ways that I think sort of make overly simple a much more nuanced conversation that Turing was opening. And there's much more to say about that, but I think it'll get us too far off topic.
Sure. Okay, Darminder.
Yeah, so maybe I just want to bring on what David just mentioned actually about, that there is this element that we do need to upskill and educate our citizens to recognize that these are just artificial systems. But I think it's that constant danger and idea of constantly thinking what is true and what is false. That's increasingly going to become more and more blurred as a result of large language models, as a result of models which are becoming more and more ability to replicate certain human behaviors. So and this is amplified with the likes of social networks and the way that we've connected in currently. So disinformation, I think, is going to be a really, really important topic moving forward. So I personally think we should try and bring in more critical thinking skills into our education system, developing that at a younger age, where some of these technologies are becoming more part of youngsters' lives effectively, both in gaming, both in social media, and those aspects. So we think about it from that perspective. Maybe we can start to educate more of our citizens to think about more critical the information that they're receiving, whether that's true or false, and how to verify that piece of knowledge or that piece of information they received. That's kind of moving ahead. But if you took it from, let's say, now, what can we do now practically? So I personally think if you take this information topic, talk about models which are now being used, let's take image recognition, for example, currently being used. I don't think at this stage we've fully understood the vulnerabilities that exist in these models yet. These ways in which we can stress test them. In a similar way that we do already in the cyber world. Cyber security is such an important topic when we talk about software systems being incorporated into our enterprises and daily systems. They get assessed, they get patched, they get verified according to these constant threats which are evolving. I think we need to do the same thing for AI, because these AI systems will be living inside certain firewalls that will exist in the future. Until recently, the National Cyber Security Center mentioned that we should be developing systems with zero trust effectively. We should be thinking about developing systems that they will be compromised. So, what kind of mechanisms should we be putting in play that are really going to help us understand more about the vulnerabilities about these AI systems and machine learning models, and ways in which we can stress test these and bring and start to talk about how we can defend against behaviors, adversaries that are going to be looking at how they can infiltrate and change these the model behaviors to achieve different outcomes. So I think those tool sets and systems need to be in place as well.
Okay. a few different points raised there. So then I'd like to sort of open this up now to anyone who wants to address any of those three areas that were raised, which kind of, they have some links between them, but I think there were definitely distinct sort of areas there. There's someone up the back there?
Good afternoon, Andrew Gordon from BA Systems. There's been a number of discussions this afternoon about ethics and the relationship of ethics to AI. I guess there's two questions really for me, because I've seen there's a lot going on in the whole field of ethics in AI, but I've often hypothesized what's fundamentally different from any endeavor or field of science and technology, because all fields of science and technology have ethical impacts and dimensions to them. So I'm guessing for me, I've often thought, what is specific about AI that's different from nuclear, that has positive and negative social impacts, or other dimensions of science and technology? So that's, I think, maybe just a comment on what you think is really critical about AI as opposed to any other field. And on the relationship between people and systems, and maybe AI systems, I guess my perspective, it was touched on earlier, is that there is, as systems get increasingly complex, I think there's a need for the people that interact with those systems to have that understanding about what the system's doing and what their relationship to it. And I think there's a incumbent on the system designer to understand the context in which the human interacts with the system. And this applies for systems that don't have any AI in it. So I think the classic, if anyone's familiar with it recently over the past few years, is the issue that occurred with the Boeing 737 MAX, which wasn't an AI system, but had a lot of flawed systems engineering in there that was at the heart of the human factors interaction between the pilot and the system. And it wasn't conventionally containing any AI, but you know, that was contributing to the actual aircraft crashing. So I guess just wouldn't mind a comment on those two areas. One is just on the ethical question in the larger dimensions of science technology, and this whole idea of designing AI in the context of human interaction.
Well, so maybe for the first point, what's special about responsible development in AI versus other areas of engineering? Maybe David wants to take that on as a sort of, since you're dealing with this in the Turing context, I guess you have to come up with what's special about AI and data science versus other areas.
Sure. Yeah. I mean, I think first off, we need to sort of think about what AI and these machine learning systems are doing in the world. And one way to classify or characterize it is that they're serving surrogate cognitive functions. They're standing in, if you will, for intelligent human action. They're almost a surrogate. They're surrogates that are acting in the world. And when humans use their minds and use their thinking capacity to affect others, to engage in activities, to make judgments about the world, just as these surrogates are doing, we're able to, in a sense, hold them accountable, right? They're bound by the reasons they may offer to justify their behavior. We hold them legally accountable, et cetera. And what's I think exceptional about AI, if we think of it in this kind of framing, is that whereas nuclear technology might have an effect on people in the world in many different ways, it's not standing in for human judgment, or it's not serving surrogate cognitive functions, which carry with it social and ethical implications that these systems are simply not answerable for. There's a responsibility gap, there's an accountability gap there. And so what the ethics and responsible innovation perspective is doing as it applies to these AI and AI systems, data scientific interventions, is it's really trying to flesh out in that exceptional kind of case, how is it that we have to take as a given that you can't hold a piece of software running on hardware morally accountable or responsible, because it doesn't work. There's a gap there in terms of how we understand normativity in the world. So what we need to do is we really need to think through what does it mean then to have these systems that are creating efficiencies, as Sylvie was saying, and operating in the world. What does it mean then to sort of guide those paths of behavior, that machine sort of led paths of behavior, guide those in an ethical or kind of morally responsible way. And so I think there is an exceptionalism there, which sets it aside, sets AI and machine learning aside from these other scientific, these other science and technology use cases. And I'll say one other thing to that quickly, which is, and this really cuts across all the three of our comments just now. I think one thing we can think about here is how AI really presents an opportunity for us to improve on things like our capacity to co-design the world together, our capacity to be critical thinkers and critically reflective about the world, also our capacity to think about bias and injustice. And I say that because the systems themselves are forcing us to be more reflexive about how it is that we weigh issues, say, just to use an example of fairness or bias in a particular situation. So, you know, when I'm thinking about algorithmic bias, right? Because we're so careful now to consider the issues around fairness and bias as they relate to AI systems, we have become, I think, much more equipped to think in a sophisticated way about what fairness and bias actually mean. And that's improving a component of our social comportment in virtue of our interaction with the technologies and trying to improve the technologies. And so I think that's also true of creating more critically thinking people, that you have these more sophisticated systems, so the citizenry needs to be more sophisticated. So just to say, I see that the development of these technologies is providing an opportunity for us to advance our own kind of human capabilities, so that we can more responsibly handle and manage the technologies.
So building bias systems helped us understand about bias. It's a bit like Feynman said, you don't understand something until you build it, or something like that. Well,
and it's because we've had to be retrospective, because it's actually been that the technology, we've treated it as getting out ahead of us, and we're reactive to the technology. And so it's just to say that, yes, you're right there, but it hasn't been a choice, I think, or it hasn't been intentional, say, that we've been biased in building the system, you know?
So maybe Darminder could pick up on the second point, which was, I think, about when you have human AI teams, then there's a requirement also on making sure you get the human part of that correct, I think. So yeah. Maybe.
Yeah, absolutely. So I think that's talk I just gave a minute ago was about understanding it, about how we should be designing systems, AI systems with human-centric views about what the impact will have on human, and thinking about it in that way, and scenario planning those situations. So, you know, increasingly, the comment was about complex systems. I think is absolutely right. I mean, basically, AI is part of the system. Therefore, if something goes wrong with the AI, what impact does it have on the systems further up the chain? And likewise, systems that feed into the AI system. And we need to start modeling these as kind of system behaviors. So, you know, we need to think about branching into some of the learnings that happen, or, you know, within complexity science, for example, who look at science and how we can model these complex systems, abstract that to high level dimensions and sort of features that can give us enough information about behaviors of certain systems. When we say systems, we talk about, this could be both social economic systems, citizen systems, example about the 737 MAX system. And it's really that through that understanding that we can therefore bring value about the impacts, assessing the impacts about what that means on the individual or the system as a whole. So I think that's going to become more and more important as AI gets embedded within these complex systems. We see to start measuring what that means from the system perspective.
Yeah, go for it, Sylvie.
Thank you. It's just, I think this is a great conversation, and I really like what David just said. And I thought one way of jumping in, your initial question was like, what's special, right, about AI? Why should we? Is there something, anything different in terms of ethical challenges when it comes to AI? When you think of AI as a tool, effectively, and my initial answer, which I think is not so bad, was to say, well, maybe we need to distinguish between actually the kind of data that these AI tools are built on, right? So for me, there's a big bifurcation between you're talking of AI tools designed on the basis of, say, genetic data or data about the bottom of the oceans, etc. Now, that's the kind of AI that, in my view, is not qualitatively different from other tools that we have to assess for ethical implications. Like all it will do is accelerate potentially discovery and perhaps amplify effects, right? So from an ethical assessment perspective, there is no qualitative difference. Where it becomes qualitatively different, in my view, is when it involves human behavior data. And why? Why is it qualitatively different? Because actually necessarily then the AI tools you are deploying, whether it's in public services or elsewhere, will be based on our past, right? It's always based on past human behavior. When you train a machine learning algorithm on data, it's going to be data from our past. And that has massive implications, actually, in terms of ethical assessment. Why? Because our past is necessarily fallible. It's never perfect. It's often sometimes very wrong. And we're always in the process of learning, process of transforming ourselves. And so the big difference in what I find both worrying and in a way fascinating about AI tools is that it forces us to consider what future we want. And it forces us to ask ourselves, actually, is there a chance that when we deploy those AI tools, particularly in public domains, we might stop doing what's probably our greatest, you could call it our mission in life, if you think of it from a big perspective as humans. We have to ask ourselves, what future do we want? Yeah, that's what ethics is about, is how should we live our life? And the day we stop asking that question is a day that would be a very sad day for humanity. And what I worry about is that when you build AI tools based on human behavior, past human behavior, then there's two risks. One is an instrumental risk. It says, well, yeah, it's based on past human behavior. So actually the predictions might become less and less accurate because our human behavior keeps changing. Yeah. So the environment within which the AI tool is deployed then challenges the accuracy of predictions that could have been accurate when the AI tool was deployed, but 10 years later, it's a lot less so, right? So that's one danger. That's an instrumental danger. But the more interesting danger, and it's kind of a dual-edged sword here, is, but what if actually we've become so comfortable using these AI tools and so comfortable in relying on those objective predictions based on our past, that we stop asking questions, that we stop changing our policies, that we, for instance, we stop changing our apprehension of crime, we stop changing our definition of arrest, which would in turn make the AI tools we're currently deploying, say, in criminal justice context. If we keep asking questions, the AI tools we're deploying today will become inaccurate in 10 years' time. But if we stop asking questions, the risk, and it's the worst, is that these AI tools, their predictions will remain accurate 10 years down the line. And that would be terrible, because it means we've stopped trying to improve things. So that's what I wanted to emphasize for me, is this bifurcation between what kind of data are we talking about here? Human behavior data or not? No, that's a big one.
Okay, are you happy with that? Wait a sec, they're not going to be able to hear you unless you got the mic. You sat in the worst seat.
Yeah, just as a follow-on question then. So therefore, do you believe that I tend to agree, there's a distinction between deploying an AI system that's attempting or to replace a human cognitive function versus something that accelerates a technical system like discovering, you mentioned, analyzing oceanic data or analyzing a physical system and improving that. So I guess, is that part of the challenge in terms of identifying the class of system, and it's, if you're building an AI system, you explicitly need to understand the cognition functions you are potentially replacing or augmenting. And I guess it does beg the question, I ask of you, that should there be a level of moratorium or I guess as well from a legal perspective, a framework which decides what class of systems are suitable. And as you mentioned quite rightly, I think that there is this danger that because of course machine learning is implicitly based on data captured in the past. So if you don't then capture data in the future, your system won't learn new, or don't decide to learn new behaviors, they won't be codified. You will sort of freeze yourself in time. So I guess the question is that does there need to be a framework which guides those? And I guess at some point, does it need to find its way into the legal system?
So
I don't want to jump. Okay, I'll jump in. Then I've just talked, so I don't want to monopolize the space here. But I think absolutely. I mean, we've been sleepwalking in some ways into situations that I deem extremely perilous. Yeah, and my first concern at the moment, my top priority, I suppose, as someone who tries to think about these things, is when AI systems are deployed in public context. Yeah, so. I mean, I'm a lawyer and a philosopher, so of course I look at, like, say, the justice system, but also health and education. For me, these are three domains in particular where, frankly, we really need to make concerted efforts to think about how the AI tools we are in the process of deploying today, how can we make them, I would call them human friendly in the sense, or you could call them future friendly in the sense of enabling a degree of interaction that means they remain at the service of how we want our future to be like, rather than freezing us, tying us to a past that might be completely inadequate. So that's probably my short answer to
that. So we've got about 5 minutes left. So if anyone has another question or comment, there's a hand up there.
Thanks everyone for your talk so far. It's something that Darminder briefly mentioned, but digital twins are a really interesting ethical space. For my industry, which is engineering infrastructure, digital twin refers to a building or part of an infrastructure network, and thankfully that's not too ethically questionable. But when we move to digital twins of people, and not just an avatar in the metaverse, and not even thinking far enough in the future of uploading your brain, I'm not talking about either of those. I mean more a basic model or a not so basic model that can replicate functions of an individual based on being trained on that individual. What conversations do we need to be having now to prepare for that eventuality where organizations may be able to create digital twins, triplets, quadruplets of a person just to perform some tasks to add value? So if your business can run a model that can do some of the tasks you do on a day-to-day, trained on yourself who's performed those tasks previously, where does that sit in terms of considering rights? Where does that sit in terms of whether we should be considering our digital twins be uploaded to data trusts or something equivalent? Is there anything in this space that the panel wanted to discuss?
Darminder?
I think there's currently two schools of thoughts that maybe could address to your problem that you described. So when it comes to sort of data privacy and how we overcome challenges of getting hold of personal data, we ought to talk about it from the perspective of anonymization. So, you know, I can have your data, but it'll be anonymized. And there's some safety guards and regulation and legal things that will back that up. You've also looked at it from the perspective of synthetic data. So you can get hold of representation examples of what you're trying to model and look to replicate that in a synthetic way. From a machine learning perspective, there's concepts about how we can federate machine learning now. So rather than having data from you, I take hold of it and put it in my server, in my centralized location, and some of the sustainability challenges and data latency challenges that will bring, how about I'll give you control of the machine learning model to you, and then you decide what data you would like to give. And there's these incentives happening now. Currently, there's just recently on the Boost Technology side, there's a website called Surf, kind of a reward type platform, which incentivizes users to share their data for their kind of personal benefit. So they get rewards on certain things that they would like to buy. And I think it's that cost kind of incentivization model that you quite need to kind of incentivize for the right reasons. And I think that's kind of builds trust and therefore ability to get hold of data. That's if you want to collect data for your own purposes. But also there's a school of thought that you can train large models on internet available data or data which has been trained by other people and transfer that learning across into your own system. And that's transfer learning. And then ability to fine tune it on the specific examples that you want to test against. So your ability to kind of start not from scratch, but at least get at least 70%, 60% up the way. And then use specific fine-tuned examples. Some examples that Sylvie mentioned about getting hold of the correct data through data trust. That data trust data can then be used in collaboration with a transfer learning model, a very, what we call a weak supervision type aspect. So you have unlabeled data that you then want to label according to the use case that you want to essentially test against. And I think that's kind of the collaboration that we probably will need moving forward. Which way people go, I'm not sure. I think it's down to the use case and the domain that you operate in, and every domain will have its own set of restrictions and challenges accordingly. But there's some of the ideas that you could look to start to maybe learn or maybe try out initially and discover for yourself.
So I think we might have to close there, I'm afraid. There's loads of extra interesting stuff I think we could talk about. And perhaps David, Darminder and Sylvie might be open to discussing things, by email or whatever. But let's thank the panel and it's close of the day one.